Okay. So as that's going live, so here, when you factor here, first step is always to common factor. So common factoring the -2, we can't common factor an x. Everything is divisible by 2. We want to factor the negative out. We want to make sure x squared is positive. So we get x squared minus 16 plus 55.
Wouldn't
Okay.
it be 16x?
Sorry, x, yes. Thank you very much for catching that. 16x plus 55. So make sure you divide everything by -2, so all the signs would change inside the bracket. So positives becomes negatives, and then negatives become positives. Once we have that, you can pick whatever method you prefer. Now that x is, the a value is 1, right? We can just use our simple product sum. And so a is 1, b is -16, c is 55, AC is 55, and we think, what are two numbers that add to -16 but multiply to 55?
-11 and -5.
-11 and -5, right? -11 plus -5 is -16. -11 times -5 is positive 55. So that brings us down here to x minus 11 and x minus 5. Once we have that down, we have to do a little bit more work here where we can find our x-intercepts, which we get x-intercept 1 should be 11 and x-intercept 2 should be 5, right? Setting each bracket equal to 0, you should get these two x-intercepts. That's where I expected everyone to kind of finish with their homework, but that wasn't exactly the end of it. You needed to go a little bit further than that. And so I'm just going to erase this section up here because I want to get some extra space for the extra work here. So I'm just going to leave it for a little bit for people to copy. But you need to, now let's go further. Let's find the vertex. So let's practice finding the vertex here, right? For our equation. So we already know what the vertex should be from method 1, 8 and 18. So let's verify that we get the same one. So if I erase this section right up here, I'm just going to shift it up a little bit. There we go. So once we have that there, we can then continue on. If you remember the x-vertex equation, right, it was x-intercept 1 plus x-intercept 2 all divided by 2. So xv, or x-vertex, is equal to 11 plus 5 divided by 2. And what does that give us? That gives us 16 divided by 2, or 8. Which matches. That's exactly what we found on the left. The vertex x value should be 8. So now that we know that, we want to find the y value when x is 8. We want to find the vertex. And so how do we do that? We plug in p of 8. So notice how I don't have to write plug in x equals 8. I can just write p of 8 is equal to, and I can just plug it in right away. Because we know what p of x is, right? So this is the benefit of function notation. Since I know x equals 8, I can write p of 8 is, and then plug it into my formula. So that's immediately going to give me and allow me to write out this. Saves just a little bit of time instead of copying the whole equation down. Right? -2, 8 squared plus 32 times 8 minus 110. And p of 8 is going to give us, well, we knew it from earlier, it's 18. So the vertex that we get, whoopsies, is 8, 18. And the conclusion is exactly the same. That's not what I wanted to do. The maximum profit is $18 million by selling 8,000 games. Okay. So this should be the same conclusion. Nothing really changes here. Okay. So method 2, if you got factoring, that's half the work. And continuing on from there, since the question is asking for maximum profit, we want to solve for the vertex, right? That's telling us, hey, find vertex. So we continue onwards. We plug in our x-intercepts into the formula and solve for our vertex. So that's going to be the full process there. Okay. The third process was to graph it on Desmos, right? You graph it on Desmos, and then that's pretty much it. So yes, I want you to use technology, right? This should have been a yes, I use technology, I use Desmos, and then include your sketch. Now, the sketch is exactly that. It's a sketch. Doesn't have to be accurate. Just draw it. Just all I need to do when I see a sketch is some key points, and that's it. So just to show you an example here, I go to desmos.com/calculator. We're going to type out our formula. So we're going to get -2x squared plus 32x minus 110. You'll notice that it didn't really fit on your graph, right? But if you click on the graph itself, it gives you some key points here. Do you see that? The graphing calculator itself tells you what the x-intercepts are. It tells you your vertex. And if it exists, it will, if we were to go all the way down, you can actually also see the y-intercept as well. So it already labels all the key points for you. So all you had to do when you were to sketch it was to include these 3 points here. So if I were to snip this here and kind of paste it here, I could do that and be like, voila, there's my drawing. And then some of you are like, oh, Mr. Choi, that's cheating. I'm like, sure. Let me show you what it means to sketch. All you have to do is something like this. Draw your x and y, and then just draw like a simple, like, ta-da, like this. Mark your 3 key points. I know that the vertex is 818. I know that this is 11,0. I know that this is 50. And that's it. That's a sketch. That's all you have to draw. If you really wanted to go all the way down to -110, that's fine. But this is all I need to see when I said include a sketch.
So whenever we have to sketch a graph, should we always just do 3 points? Or just
draw your key points. When you sketch using like a table of values, right, you should use like 3 to 5 points because you have the values. But if you're just doing a quick sketch with just information where you don't have the table of values, like I have the x-intercepts and the y-intercept, that's plenty. The x-intercept and the vertex is enough to draw your shape, so that's plenty, yeah.
Okay, and what about for the assignment? Like, would you want us to do like only 3, or should we do more?
If you can do 5, that's good. So for example, if you have, let's say, for example, we have a graph. I'm just going to erase this. Sorry, guys. So I'm just going to quickly erase this. Let's say I have something like this. Let's say you drew your, like a couple points. You drew your vertex and your 2 x-intercepts, right? That's 3. Let's say you already found your y-intercept as well. And let's say the y-intercept was like 0, 3. This was like 1, 0. This was, let's say 3, 0. This was like 2, -5, for example. I don't know, some random numbers. You technically have a 5th point, which is right here. And you can actually call that 4, 3. Why is that possible? You didn't even solve for this, but you should know it once you graph it. Any ideas why?
Because the y-intercept is the same as that one?
Yes, exactly. It's symmetrical here. So it should be evenly spaced out on the other side. So if it's 2 spaces away from the vertex in the x, it should be another 2 spaces to the right on the same level. And so those would be your 5 points there, right? So draw as many points as you can, and then if you can use symmetry to find your last one. 5 is nice, 3 is their minimum. But yes, so that's all I want from your graphs there. But I'm going to put this one because this is nice. And of course, the conclusion is exactly the same, right? Maximum profit is 18 million. Nothing changes there. So then the question is, which method is most appropriate? Is one better than the other? Personally, or actually, let's do a vote. Let's do a quick vote. Give me 1 second to set up the poll. Okay, which method did you prefer when you solved this for your homework? 1, 2, or 3? Just gonna give like another 20 seconds. Okay, so just to kind of share the results here, it's a pretty even spread overall, right? Is one better than another from what you guys are telling me? No, not exactly, right? And this is why I give you the option of doing different methods. However, is one method more appropriate than another? Yes. The best method you should be using, keyword is should, not that you have to, but you should be, is method 2. Method 1 is preferable for people who like just plugging in the number and doing the algebra. It's quick, it's easy. It takes a little bit of time, but you can get it done, right? Nothing wrong with that. Method 3, some may prefer because it's quick graphing. You can graph it, you're done, don't have to worry about it. It's like, yes, that's true as well. You don't have to show your work, it's on the graph. But obviously, I can't let you do that on a test. You can do that for your homework to check your work, absolutely. You should be using Desmos to check your work if you can. I think it's a good resource to do so. Just like Photomath, I know at least some of you use Photomath to check your work as well. It's a good resource. I'm not saying don't use it. I'm saying use it to check your work. There's a difference. Okay? Don't use it to solve it for you. But method 2 is the best for a couple of reasons. Number 1, it shows all the work and it's faster than method 1. A little bit faster if you understand how to do it. It cuts out all of the unnecessary points. You don't have to find out what's in between the x-intercepts. You don't have to find out what's in between the vertex and the x-intercepts. Like none of that. You can quickly plug in for x-intercept, solve for y, x-intercepts, plug in for y, find the vertex. Boom, boom, boom. Done. That's number 1. Number 2 is that method 1, let's say the vertex was at like 25, 40. X is 25 and Y is 40. You need to keep going until you hit x equals 25. And I think you can see where that issue becomes. Your table of values will now start from like -2 all the way to 25 because you're like, wait, this keeps going. It's not turning around. It's not repeating, right? And you run into this issue where you're going on forever for a little too long, right? We don't want to fall into that trap. So yes, method 1 is fine, especially when you know where the vertex is and it's not going to be really far down, right? At like x equals 25 or something like that. You can definitely do method 1. But method 2 avoids all of that because you're quickly solving for the points that you require to solve for those key points, right? So I would prefer you learn to use method 2, right? Because it cuts down on the like unnecessary solving that you have to do, right? Speed-wise, method 3 is the fastest, but you can't use that on a test, so can't really do that. All right? Any questions here? Okay. Let's move on to 4.1. And I need to make sure we take attendance. Is anyone late? The people that were late when I marked it. What? What do you mean invalid credentials? I know my password. All right. I believe so. It was Haley, Marab, Nyack, Devon, Wilshire, and Stefan. Are any of you here that were late? Those are who I have marked absent. Stefan
Yeah.
is here. Okay. Perfect. And then who else? Don't worry about the time that you're late. That actually doesn't matter. Anyone else? Haley was I marked late, yes. Wilshire's not here. Devon's not here. Nyack isn't. Nyack, okay, Nyack, hello, are you there? Great. Want to tell me that you're late because I called your name out? I'm not sure if it was you or Stefan. I'm pretty sure Stefan was the one who told me that it was late. So I don't know. I could have easily just marked you absent. It was like right there in front of your face, and you didn't even tell me I could have easily just marked you absent and saved it. Next time I'm gonna do that. Like I said, if you're late, tell me you're late. That's the point. Unless you really want to be called absent at home. I mean, I guess that's up to you if you're really masochistic. Okay? Say that you're late. Also tells me that you're not paying attention. Right? If you don't tell me. Okay? Or if I call your name and it takes you a while to realize that I called your name.
Quick question.
Yes.
What unit are we doing next?
Unit 4.
No, like you said.
Oh,
the
after Unit
quadratics.
4?
Yeah.
After Unit 4, I believe is exponential functions.
Yes.
So it's Oh, no, I lied. It's trig.
No.
Yeah, it's trig. It's trig, and then it's exponentials after that.
Oh.
Sorry. So you have SOHCAHTOA stuff, sine law, cosine law, sine function, cosine function, and then we jump into exponentials. So exponentials is at the end. All right. So jumping into 4.1 here, your last unit for quadratic functions. Stay strong, everybody. We're almost there. We're pushing through. So chapter 4, working with quadratic models here, the vertex form of a quadratic function. The quadratic function can be written in the following form, and we've already known this, right? We know this. We've seen it before, right? And this is what we use to determine our transformations. We talked about before, vertical stretch was our A value. Horizontal shift was our H value. Vertical shift was our K value. And the specific name for this form is vertex form. And we know that the vertex is H comma K, right? This form allowed us to get the vertex right away. And the axis of symmetry is X equals H, right? What the x value of the vertex is. And the direction of opening, we just look at the a value. If it's positive, it opens up, and negative, it opens down. So this is just review of what we did in Unit 2 and Unit 1, right? Understanding when we have vertex form, we can figure out the transformations, we can figure out the vertex, we can figure out the direction of opening, right? So this is just review of what we've done so far. Then after that, we talked about the quadratic function in its standard form, which was y equals ax squared plus bx plus c. And this one, we can simply find the y-intercept, which is the c value, which is 0, comma c. That was pretty easy. So the benefit of the standard form was that this is your y-intercept, right? Boom, y-intercept. No need to plug in anything. You just say y-intercept is this, and I'd give you the mark because it's in standard form. Then the last thing we did from Unit 3 was to factor it and tell me what are the factors. And what the factors give us is going to be the x-intercepts, which are the zeros, which is x equals r and x equals s, right? And don't worry, r and s are just random values. We know how to solve it in case it's not just r and s, right? We set each bracket equal to 0. Set each bracket. I'm going to write that in. I'm going to type that out because it's taking me forever. So how we solved it, set each bracket equal to 0, then solve for x, right? That's essentially what we're doing here to solve for our x-intercepts. So set each bracket equal to 0, solve for x, done. Okay? Now, from here, let's just review. So 4.1 is pretty much a review of, hey, do you remember all of your previous information from previous units? All of the properties and stuff like that. So let's review that. Because look, you can see domain and range is back too. Domain and range, isn't that great? Okay. So let's talk about each and every one of these. Okay, vertex form, we've done it enough. This is just practice here. Okay. There should be no hesitation here. I'm going to call a name. There's going to be 6, what is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 people I'm going to call out right now, one by one. And we love, you know, I love using my RNG on Google, random number generators on Google. Okay. Here we go. We have 22 people in the class today. Let's see who goes first. Number 12. 4, 5, 6, 7, 8, 9, 10, 11, 12. Josu, what is the vertex here for our first one? Josu, what's the first one here? Josu, you there? Okay, Josu's not there. We'll find someone else. Angela. If you don't know, just say you don't know.
1 and 5.
It's okay to say. Well, could you say that one more time? Sorry, I cut.
1 and 5.
Close. Not 1, but
1 squared.
no, -1.
Oh.
Opposite sign, right? So just a reminder, it's the
Yeah.
opposite side. Good, but that's good. You have the number. So 1 and 5, she was looking at H and K, which is perfect. Just remember that this is the opposite sign of what you see, which is great. Perfect. Thank you very much, Angela. Next one would be 17. Nicole, what's the vertex for the next one? Once again, if you don't know, just say you don't know. If you don't respond, I'm just assuming you're not paying attention. That's my assumption. This is how I get forceful participation. Nicole, going once. Going twice. Okay, that's a strike for Nicole, and that's a strike for Josu. Next person here. We can't do the same person, so we're going to do one after that. So Ashley, what is the vertex for our next one here?
-4 and -8.
Close, not -4.
4.
4. Good, just 4. +4, -8. Take the opposite sign of this because the h value doesn't include that sign. Very good. And the last one here for the vertex is generate Lorraine.
-5 and 0.
-5 and 0. There is no k value, which means it's 0, and -5 because it's +5 in the bracket. Perfect. Done. Next one should be even easier. The axis of symmetry here. Okay. Jonathan, what is the axis of symmetry for our second row here? This one right here. X equals no, Jonathan. Jonathan's the one that should be answering this. Yeah, no worries. Jonathan, you there? Going once. Going twice. All right, that's a strike for Jonathan as well. Let's move on to one after that. That would be Joy. Joy, what is the axis of symmetry for this one here? This one here, sorry, in the second row. Yes, -1 is correct. Perfect. Thank you. So x equals -1. You're honestly just taking the x value of the vertex. That is the axis of symmetry as it goes down through the vertex. Very good. Next person is Fatimata. What is the axis of symmetry here?
4.
4. Perfect. Last one, we're going to do, we'll just go one above. David, I'll try the last one here, please. What's the axis of symmetry here? Perfect, -5. Easy peasy, these were easy, right? Just once you have the vertex and you're able to identify that, axis of symmetry is exactly just that. The x value of the vertex, x equals that. It's an equation because it's representing an imaginary vertical line. So that's the axis of symmetry there. Direction of opening should be fairly straightforward as well for most people. Once again, if it's a positive a value, it opens up. If it's a negative a value, it opens down. So 21 is going to be Stefan. The second row, is it opening up or down?
Down.
Ooh, not quite.
Oh, down. I think I made a mistake somewhere.
It's up. So it's specifically here, right? We're looking at this value. You probably thought it was down because it was a fraction. So the value actually doesn't matter. It's just whether or not it's positive or negative, right? So Stefan, why don't you do the next one for me then?
Okay. When it comes to, okay, here it's down because it's a negative, but
Bingo.
when it comes to fractions, like, I'm bad with that one. I'm sorry.
No, that's fine. Like fraction, what the fraction tells you is whether it's a stretch or a compression. So if I ask you for a transformation, that's what the fraction would matter. When I'm asking you for direction of opening, the sign is the only thing that matters. Doesn't matter if it's a
Oh, got
fraction
it.
or not. Yeah,
Thank you.
exactly. No problem. Perfect. And the next person after that would be Christian. Opening down or up?
Down.
Perfect. Down. It's negative. A value is negative, right? At the very front. So it's going to be opening down. Perfect. Now we have to think. So the next three people, you guys just have to think a little bit. Visualize where the vertex is. You know that it's opening up or down. And see how many times does it touch the x-axis. That's all you have to think about. It's either 0, which is none, 1, or 2. Okay? So it's either 0 x-intercepts, 1 x-intercept, or 2 x-intercepts. So try to visualize it. This is now getting a slightly harder than the other questions. But let's kind of go through and make sure we can do it. Wow, this number generated loss gives me the middle. I think the middle who hasn't answered it here would be Haley. Number of x-intercepts here. 0, 1, or 2 for this one here. Saying this is 0. Perfect. So there should be none. That's good. So Haley said 0. Right? If you visualize it on a graph, if you wanted to quickly graph it, you draw -1, 5, which would be up here, and it's opening up like this. So it doesn't touch the x-axis. So 0 would be correct. Very good. Right? So quickly sketch it. Doesn't hurt to just quickly sketch the vertex. Doesn't have to be accurate. You should know exactly where it is. Okay? Next one. 8. 1, 2, 3, 4, 5, 6, 7, 8. Looking upwards would be Brooke.
I'm not sure, but I think it's 0.
Not sure, but you think it's 0? Let's check. So if we quickly graph that as well on the graph here, 4, -8, 4 on the x would be on the right side, -8 would be down here, opens down, looks like 0 to me. So 0 is correct, opening downwards like that. Definitely no x-intercepts. Very good. And the last one here, 20, would be Rena. And Rena's probably thinking, damn it.
Rena's really upset right now.
What's the x-intercepts here?
I will let you answer this one for me.
Okay, we'll have someone
I
else.
don't
then.
know.
Have the next person. It's okay. If you don't know, you don't know. Nyack. You don't know. Okay, let's keep going then. Kimberly. Kimberly saying 0. Okay, let's check that. So, and Angie saying 1. So let's check. Is it 0 or 1? Right? So when we graph it, -5, 0. Oh, Nyack saying 1 now. Okay. So -5, 0 would be -5 on the x-axis, 0 on the y, which means the vertex is on the x-intercept, and it opens down, which means the answer is actually 1. The vertex itself is the x-intercept. So it's actually just 1. And that's going to be your answer. So a good way to see that is if your vertex itself is on the if the vertex itself is on the x-axis, then it's only one x-intercept. Now, I'm not evil. I'm not going to let people do domain and range because I think that's significantly harder. But the people that didn't do it or didn't answer so far would be Amir, Katayun, and I think Sydney, right? And Sophia. Does any of you want to try the domain and range for any of these?
I'll try one.
Okay. Can you try the first one here?
First one, XER, and then YER is greater than or equal to 5.
So YER, and then you said y is greater than or equal to 5. Perfect. And that is correct for the first one here. So let me break it down here for people who are confused as to how Sydney got this. The domain is XER. What this means, XER in math means that X can be any real number. And a real number includes decimals, negatives, and positives, right? So it can be any number in between because it's a smooth curve and it hits all the numbers going all infinitely to the left and infinitely to the right. The range is your y values, and when we sketch this, right, and it's -1, 5 up here, and we sketch it, the y value cannot go any lower than the vertex itself. And because it's opening up, that tells us that it's greater than 5. And the 5 is just the y value of the vertex. That's our lower limit for this case. So YER and XER are musts. You should be writing that down. And then y is greater than 5 for us, right? Because it's opening up. Which leaves us with Sophia, Katayun, and Amir. Would any of you like to try the next two?
Yeah.
Sure. Sophia, try the next one here. What's the domain here?
Okay. Domain is x equal r.
Mm-hmm.
And
the
range
range?
is y equal r.
Mhm.
Y is lower than -8.
Perfect. And you're just missing the or equal to. But yes, that
Or
is right.
equal,
Less
yeah,
than or
yeah.
equal to -8. Perfect. That looks good to me as well. So we have, once again, domain is XER. For a parabola, there's no restriction on the domain for a regular parabola. And as Sophia said, it's less than because it opens down. This is what causes it to be less than. And then -8 is just the y value of the vertex here. All right. Amir, do you want to try the next one?
Yes, sir.
All right.
E equal XER
Mm-hmm.
and R equal YER. Y is less than 0.
Less than or equal to 0. Perfect. Thank you very much. Well done. Perfect. Don't forget this line here. This line means such that. It's kind of saying like, hey, y is any real number, but it's like a but in English. It's like, but y has to be less than or equal to 0. So don't forget this line here. This is a very important line, right? It means it doesn't look like much, but it really, in math, it's very important. It means it's like the but of math, right? So y is any real number, but y is less than or equal to 0. Okay, so perfect, very good. So this was just a general review of what we've done so far with vertex form. I know some people were not here for this, right? I know David wasn't here for this, and I know Angie wasn't here for this because you guys joined the course a little bit later, which is fine. But this is good review overall for the class as well to make sure that we're all on the same page as we move on into the next portion. Because when we talked about vertex form here, right? When we talked about vertex form, the issue was that over Unit 2 and Unit 3, we didn't work with vertex form. We've been working with standard and factored form, and we never went back to vertex form. So the question was, when do we get to use it again? Because for some of you, it's like, how do we even get there? We've never even seen it. It's either I give it to you or I don't. And so that's what 4.2 is. How can we solve for vertex form from standard form? This is where it gets tricky. Some of you who took grade 10 academic may have learned this already, which is great. That's review for you. For those who took grade 10 applied, you have never done this before. Okay, so this is new content for at least a good portion of the class. So we will be taking it slow to make sure that everyone is on the same page. So if you've done this before, that's great. This is good review. And if you haven't, that's fine. I'm taking it as if no one has learned this before. Okay, so we're going to be taking it slow. So that's 4.2 here. Okay, these steps seem very complicated, but so we're going to take it very slow one step at a time, because this is pretty important. Okay? So, to connect standard form and vertex form is something called completing the square. We are going to be completing the square to make sure that we can transform standard form into vertex form, because we never learned how to do that. We've learned how do we get from standard form to factored form. We've learned that. How do we get from factored form to standard form? We've learned that. But we never learned how to get to vertex form. We know how to get from vertex to standard, but not the other way around. So now this will pretty much cover all the bases. If I give you an equation, you should be able to convert it to any of the other two types once you're done with today's lesson. Essentially is what the end goal is. So we need to know maximum and minimum for a quadratic equation, right? Because whenever we see these two words, if you haven't written it down already in your notes, maximum and minimum refer to the vertex. This is referring to the vertex, right? If a question asks you for maximum height or minimum cost, whatever it might be, right? It's asking you to find the vertex. And the thing is, for some of you, you're like, I don't want to factor it to solve for it. That's a pain. I would rather just get to the vertex as soon as possible. This is one way you can do that. Okay? So we want to convert from standard to vertex. Okay? So we want to convert from standard to vertex. That gives us our vertex form, which gives us our vertex. So completing the square is the method that we're going to use, and it goes through a couple of steps which may look daunting to some of you already. There are 5 total steps here that you want to do. Okay? There are 5 total steps. I am going to change up just a little bit to clarify how to do it for some people, because I feel like some of these steps, when we do it at the same time, it might be confusing. So I'm gonna break it down another way after this example. Okay. So here, the first step is to common factor the first 2 terms. We only do these first 2 terms. We ignore the last value. We ignore C. You'll notice that C is left alone. And the reason for that is because we want to be able to manipulate the X terms. We want to be able to work with the X terms here. So we only common factor the value in front. Not only that, it doesn't matter if it divides evenly or not. Okay? The end goal is in the bracket, X squared should be 1. So we are common factoring out the A value no matter what. That is a must. We must common factor the X squared coefficient. We have to. Okay. Then we do some kind of middle step here, which is something like this. The formula for the middle step here is that we take this value, okay, which is our B value, and we do this here. So please write this down. This is your in-between step where we divide the B value by 2 and then we square that value. So when we actually solve this out, we get 6 divided by 2 is squared. 6 divided by 2 is 3. 3 squared is 9. And then we stick that in back into the bracket here. And you'll notice that we do it twice. Anyone who has done this before, so if you were in grade 10 academic, do you remember what the reason was as to why we subtract this number?
To make it 0?
Yes, to make it 0. What's the point of making it 0?
So you can get rid of it?
Not so that you can get rid of it. It is true, it would, if we were to simplify it just then and there, it would get rid of it, but that's not the purpose of it. The purpose of adding 0, there's actually a couple things in math that we do. If you were to take math in the future, some of you might not, some of you may, you will start to realize that there are some methods in math that we use to make sure that we don't change the equation. So for example, if I ask everyone what's 2 plus 2, we can say, oh, that's easy, that's 4. But we can't just add stuff to it. Like if I add a plus 1, that doesn't equal 4. It doesn't work. But if I say plus 1 minus 1, for example, that's still 4. We're adding 0. So adding and subtracting a number is essentially just adding 0, which means nothing is changing in the equation. What that allows us to do as mathematicians is start working with this extra number that we have with the equation for our benefit, right? So doing this benefits us, and we're going to see how that benefits us here. So that's the reason why adding 0 is important. We're adding numbers without changing the definition of our equation. That's the whole purpose here. So once we do that, what happens here then is we take this section here, I'll do it in purple. This portion here changes to this portion here. We are factoring this trinomial here into this form. Once again, I'll take it slow with another example, but we are factoring this to get a square. Okay. In doing so, right, this is actually the main part of our vertex form, right? X minus a number squared is what we want. So by getting our 9, that extra 9 that we just added in, we're able to actually factor it very nicely into a perfect square. Then we can take out the negative 9 by pulling it towards the outside, but when we do so, we have to apply the a value. Anything that pops out needs to be multiplied by the 2, and so that's this section here. Okay. Notice how it has popped out of the bracket, and it is now outside of the bracket being multiplied by 2. The rest of the step is to just simplify. Okay. So seems a little complicated, I know, which is why we're going to try it one more time, and I'm going to go through it one more time for you, right? And once you get to the end, this is where you can say, oh, the vertex is here, -3, -23. So that's how you get the vertex. And some of you are going, okay, Mr. Choi, I understand. I'm just going to factor it and find my vertex. I prefer it that way. That's fair. And that's completely fair. But yes, there will be a question where you have to do completing the square once. So you gotta at least learn it. I'm sorry. I know you don't have to use it all the time, but there will be at least one question where you do have to complete the square. So I'm sorry. I'm telling you now, you will have to learn it, at least for one question. Okay? So let's express each form in vertex form by completing the square. And let's state the axis of symmetry and the coordinates of the vertex. So I'm going to go through at least 2 examples here, and I want you to try some yourself as well. So for here, y equals x squared plus 4x. The first thing I do, step 1, usually is just to put brackets around my x terms. What that helps me do is to kind of isolate these two and say I'm working with this separate from everything on the outside. Okay, so this is step 1. Put brackets around the 2x terms so that you don't forget. Okay. Step 2, we're going to be doing our side work here with our b divided by 2 squared equation. Our b value is 4. And so we're going to do 4 divided by 2 squared. We do the bracket first. So 4 divided by 2 is 2. 2 squared is 4. So it turns out we get 4 back. And so our next step here would be writing in this 4 in the bracket as plus 4 minus 4. So this comes in and drops in here and drops in here as plus 4 minus 4. That is essentially adding 0. So that gives us this here. Once we do that, the next step I do a little bit differently. I actually don't factor it here. I wait one step before I factor. But essentially, I'm going to pull out the -4 outside of the bracket. So this next step is me pulling this out of the bracket. Because the coefficient in front of the bracket is 1, nothing is changing. It's going to become -4. Okay? So that's going to be your third step. We pull out the minus part. Keep the plus inside the bracket, pull out the -1. So the -1 gets pulled out, and then the final step is to factor. Now let me show you a quick way of factoring this. Take the middle number and divide it by 2. What's 4 divided by 2?
2.
2. So it's just x plus 2 squared. And that's it. And you're done. So that's the fast rule.
Difference of squared questions.
Could you say that one more time? Sorry.
Can that work with any of the not difference of squared, completing the square questions?
Yes, it will work. As long as you factor out at the very beginning, it will always work. That is correct. So this is how I personally like writing it out. So this kind of helps you realize, oh, now I can factor it now that I've pulled everything out. And boom, we get our factored form quickly by dividing the middle number by 2 and putting a square on it. And then I ask you, what's the vertex here?
-2, -4.
-2, -4, and the axis of symmetry is x equals -2. And that's your full answer. Boom, done. Okay?
Wait, quick question.
Yes.
Because you pulled that out and you divided the 4x divided by 2, then the +4 doesn't really matter what happens to it, right? Because like
basically we've covered it by factoring it, right? So if you were to expand this x plus 2 squared out, you should get this back when you expand it already.
Okay.
Yeah. So it's already been covered by factoring. So we're going to try one more. I'm not going to do this next one. I want you to try this next one on your own. But we're going to do this one because I know people are going to complain about fractions, right? They're like, Mr. Troy, you're making us do fractions? All right, I'm going to be the nice one and say we won't do fractions. Okay? So
can you not
I'll
put them
do the
on
one
the
with the
test
fraction.
Can you
Say
not
that
put
again,
them on the test? Can you not put
Did
them
I
on
not
the
put
test?
them on the test? I don't know. Now that you've said not to put it, I kind of want to put it on the test.
Oh, Mr.
We'll
Troy.
see. We'll see how evil I feel on the day I make the test. So let's at least cover it. Look, fractions may be difficult or may seem difficult. It's not that bad. So first step is the same. Remember how I said first step is draw brackets? We're going to be drawing brackets around our x terms. Okay? So this one, we have a c value. We're not including the c value inside this bracket here. Do not include it. Okay? That's the whole first step. Isolate the x terms, just put 2 brackets around it, make it nice and clean. Okay? Then, what that does for you that we didn't do in our first example is now we can visually see I am only common factoring out the x terms, what's in the bracket. So we want to factor out the a coefficient, which is -1/3. So you're going to pull that out of the bracket and factor everything in the bracket. So you should be left with x squared because that's the point. But what happens to the 3? Anyone know? What is 3 divided by -1/3?
2?
No.
Oh.
Not 2. Fractions are a little weird. If you divide by a fraction, it's multiplying the reciprocal. This actually turns into 9x, -9x, -4. So if you do this, dividing a fraction is multiplying the reciprocal, if you guys remember that. So it's technically multiplying this by -3. Okay? So -9x. And that's why I said I'll do this one, because I know some people are going to be like, how are we supposed to know that, Mr. Choi? It's like, well, you should. But this is an example, so you can do it for the next time, right? So let's just do a quick example here. If I give you like 1/2x squared plus 4x minus 2, and I ask you to common factor this out, if you pull out the 1/2, what does 4 become?
8.
Perfect. 8x minus 2. Good. That's the idea. Very good. So depending on what the fraction is, you want to do that. Okay? Of course, we may go through more difficult fractions, and we'll go through examples of that in the future. But for now, that's all you have to worry about. From here, then we can do our next step. So this is our side step now. So we do our whole b divided by 2 squared step here. So that's going to give us, our b value is now -9 divided by 2 squared. And some of you are going, what the? You can't divide -9 by 2. It's like, well, just keep it as a fraction then. nothing wrong with keeping it as a fraction. So what this becomes is something kind of gross, but you can technically still work with it. You can put this in 2 ways. If you keep it as if you turn it into a decimal, 9 divided by 2 is 4.5, or -4.5, sorry, squared. And if you do that, 4.5 times 4.5, we get 20.25. If you want to keep it as a decimal, you may do so. That's fine. Solve it out. If you don't want to do that, and you want to keep it as a fraction, then you would get 81/4. Okay? Doesn't matter which one you pick. I think most people will prefer the decimal, so we're going to use the decimal form. So here, what happens is, once again, we write out everything. And inside the bracket is where we write our plus 20.25 minus 20.25 minus 4. So we are plugging, once again, the 20.25 into these spots as a plus and a minus. The step after that is to take the minus 20.25 and pull it outside. But to do so, we need to multiply our common factor. So what we do here is we multiply -1/3 times -20.25, which is just dividing it by 3. And I get 6.75. So make sure you try this on a calculator now. Don't just copy it down from me. Okay? What you should be able to get here when you multiply it out correctly is this. Notice how everything has stayed the same, and on the outside we should get plus 6.75. So on a calculator, try it. -1/3 times -20.25 should give you plus 6.75. Okay? Make sure you try that on a calculator. Don't just copy it now. The whole point is that you should be able to try it and do it yourself now so that we don't make a mistake in the future. Okay? Then from here, we can now factor inside the bracket. And then we're going to simplify this as well at the same step. Okay? So that's going to save us a little bit of time here.
Wait, mister, what did you multiply again?
So if you see here, I'm multiplying -1/3
And
with the 20.25, the -20.25. So that's why I drew the arrow here to multiply, to show that I'm multiplying.
I got 60.75, but anyways.
You don't. So since you're multiplying by 1/3, right? That's now, since you're multiplying it, that's technically dividing by 3.
Okay.
Yes. That's why fractions are weird, right? So be very careful. So you should get 6.75. From here, once you get that 6.75, we can now factor. So here, let's use that rule. We take the b value, the center value here, we divide it by 2. So what's -9 divided by 2? What's the decimal?
-18.
Dividing by 2?
Four
Not negative.
point five.
Negative 4.5. Yes, you multiply by 2, so you want to divide. So you get negative 4.5 squared. That's it. That's the factor. Then we add this at the end. Negative 4 plus 6.75 will give us plus 2.75. And that's your final answer. Okay? So that's how you complete the square, right? And so when we put it into our vertex, we would get 4.5, 2.75, and then for our axis of symmetry, we'll get x equals 4.5. And I think you guys can see that method 1 from your homework, the table of values, would completely fail in this portion because it doesn't cover decimals. So it's very, very important that you try not to use method 1 as much as possible, at least when we start getting into these complicated ones, right? We want to make sure we can actually find exactly what the vertex is. Okay? So now I'm going to give you time to try one yourself. I will keep this one on the screen for you. If you've copied it down already, that's good. I would like you to try question B on your own. I'm going to help you start it off, which is to draw the brackets around the first two terms and common factor. Then try doing this process yourself now. Okay? So please give it a shot, and we'll take it up in 6 minutes. I'll give you 6 minutes. Okay? Good luck. If you have questions or get stuck, let me know in chat. I'll try to help you out. Okay. You should be finished. Let's take it up. If you got stuck, that's okay. Hopefully it's not blank. If you wrote a blank, that's not okay. If you wrote something, that's okay. Once again, the one thing that I don't like are blanks. Blanks are no good to me. I don't like blanks. So let's continue onwards from here. First step, common factor out. Whatever the a value is, you want to pull all of that out. So when we pull out a -2, we divide by -2. You should be left with x squared plus 8x plus 1. So the plus 1 is not touched. You should be left here. This moves us to our second stage. B divided by 2 squared. B is 8, which gives us 8 divided by 2 is 4. 4 squared is 16. So when we write down our next line, we get x squared plus 8x plus 16 minus 16 plus 1. Someone asked, can it be -2x? No, it cannot be -2x because we're dividing by -2. -16 divided by -2 is 8x. So there's only really one way to do so. So then, continuing onwards from here, we're going to pull out the -16. But to pull it out, we need to apply what we common factored out. So we're going to multiply that. And so what's that going to give us? We get x squared plus 8x plus 16 still in the bracket, plus 1. And on the outside, -2 times -16 should give us positive 32. So -2 times -16 is positive 32. Then we can quickly factor the bracket. We take this middle number, divide it by 2. So 8 divided by 2 is positive 4. So we get x plus 4 squared. And then 1 plus 32, hopefully people didn't have trouble with that part, plus 33. So this would be the vertex form, which gives us our vertex here, -4, 33. And the axis of symmetry is x equals -4. If you got halfway, that's good. Work on the second half. If you were unable to understand the beginning, take it one step at a time, right? I want you to try practicing. Like, if you have like multiple questions and you're like, I can't even get through the first part, how do you expect me to do the second? It's like, well, write out all the questions, do the first step for every single one of those questions, then do the next one, then do the next step for every single one of those questions, then do the next step for every single one of those questions, right? Why move on to the next step if you're not even ready for the next step, right? So understand the first step, do it for everything. Understand the second step, do it for everything, right? Then you're solving all the problems, but you're doing it at a step where you can understand it, right? And you're getting the same practice at the same time for multiple questions. So that is another method you can use to practice your questions, practice your steps, okay? So,
Quick question. Sorry.
yes.
Okay, this might sound dumb, and I wrote it as negative at first, and then I got confused. But why is the axis of symmetry x equals -4? Is it the opposite of? Yeah. Anyways, that's the question.
So the vertex, you'll notice that it's the opposite sign because the regular vertex form is ax minus h squared plus k. So the minus is actually not part of this h value here, right?
Mhm.
So if you see a positive, then technically it should be this. Does that make sense? Because that simplifies
Oh,
x plus 4. So
okay.
as a result, h becomes -4.
Okay.
Right?
Thank you.
No problem. So that's why we do the opposite sign, because the negative sign in the vertex form is just part of the form itself. All right. With that being said, there are some algebra tile demos, but you don't really need to do the algebra tile demos. It's just an extra sheet. If algebra tiles help with you, there are some examples with algebra tiles, but this is better if we have physical tiles. We don't really have that. So you can just ignore the third page. So that is actually it for today's lesson, right? So for the next 30 minutes, it's 10:30. We got lots of time here. Let's look at some of the questions that I would like you to try before you leave for asynchronous work. Okay, so I'm